In this last couple of videos, we're going to use what we know about sine and cosine to find the area of a triangle that is not a nice triangle. Maybe you don't have the height. It's not a right triangle, or your height isn't given. So there are ways that you can find the height, even if you have something like number one, where the height is not given to you, and you can still find the area of that triangle. Just to kind of circle back to law of sines and cosines, if you come across a problem that doesn't feel like you can use one or the other, just bear in mind that sometimes you have to use both. So you may have to use the law of sines to find a missing angle, and then use that missing angle that you just found, and then the law of cosines to find a missing side or something like that. So sometimes you do have to combine those laws to find what you need to find. But together, you can find anything that you need to find, side or angle, in a triangle. So just keep that in mind when you come across those problems. All right, so back to area of a triangle. Remember that the area is half the base times the height. And if we look at this triangle to the left, we know that sine is the opposite over adjacent, or I'm sorry, over hypotenuse. So if we're looking at C right here, then we're talking about this opposite, so this leg. So we're kind of like ignoring this part of the triangle, and so we're using the opposite, which here is h, or the height, over the hypotenuse of that inside right triangle, which is A. So because we can use that math to kind of extrapolate that the sine of C is h over A in this particular triangle, then that means that the height is A times the sine of C. So think about, if you had to rearrange this literal equation style, that you would just multiply A over here to sine C, and you would just have H left. So that means that you can substitute that information into the area formula in place of H. So that means then the area would be half the base, which you always can have a base. Anything can be the base, as long as the height is going straight up from that. And so then you would have half the base times A sine C, like that. You may also see this written as half A B sine C, with like everything in order. That those are the same. It's just the multiplication in there has been rearranged. So whichever one, that's fine. Okay, so number one here is kind of a simple one to start out with, because the base is clearly 12. So that does make your life easier. So we have that, like, this is going to be C, and then we've got A and B, like so. So we can do, so this would be A, this would be B, or that would be C, and then this would be little a, like that. So area here would be 1/2, and then A is 12, or B is 12, whichever way you've labeled it, and 15. So you're just going to take the legs, whatever is there are those legs, and then the sine of the angle 110. Okay, so basically this kind of setup is similar to law of cosines, where you've got that side angle side situation. This is super easy because this can go right into your calculator right the way it is. I would do 0.5 instead of trying to do a fraction. So I'm trying to type too fast. So 0.5 times 12 times 15 times sine of 110. So the area of this triangle is 84.6. We're supposed to round to the nearest tenth. And then these are centimeters squared. Remember, area is always squared. That's it. That's all you have to do when you have a side angle side situation. Okay, when we move to number 2, we have all the sides, but we still have an angle. So that's really good. That means that this is going to have to be C because that's the angle we know. And then it doesn't matter. These can be A and B, whichever direction. So that means we've got B, A, and C. Don't put C into your formula. That's why I'm pointing this out. So you want to use everything from that line up is what you're going to use. So you're going to have the area equals 1/2 6 times 8 times the sine of 72. And so then you can just type that in again. And sine of 72. And so the area of this triangle is 22.8 meters squared. Okay, so as long as you have the two sides and the angle, you're good. This one, you're going to basically use everything from that line below, okay, because you've got the two sides and then the angle in between them. So you're going to have area equals 1/2 23.5 24 and then sine of 25 like that. So again, you can type that in. Make sure that you've typed everything correctly. And so then the area of this triangle is 119.2. This is in inches squared. Okay. Number 4, we've got the same thing. We can use, well, this one, because we have these two bottom angles, we need this one that's missing. So you would need to do 180 minus 34, or 34, no, 81 minus 43 to get this angle. So do that real quick. Minus 81 minus 43. So that's going to be 56. So we're going to do half of 34 times 49.2 and then the sine of 56. So that's how you have to do one like that where that angle is missing. Thankfully, we had the other two angles so we could find that easy with subtraction. So oops, I left out my 4. So 1/2 times 34 times 49.2 times the sine of 56 gives us an area. Oh, that's a big one. 693.4, and this is feet squared. Number 5, same thing. You've got that the angle that you need is missing, so you're going to do 180 minus 24 minus 31. So, and then this is going to be 125. So you're going to do area equals 1/2 17 times 14 times the sine of 125. So the area here is 97.5 meters squared. All right, so I'm going to go to the next page in another video so that because they get a little bit more complicated. These were obviously quite simple.